order to kind of leverage this technology to do things that we've never been able to do before, that a few of my co-presenters will handle. So to start off, I wanted to ask a question. What is everyone's favorite public space for the web? Does anyone have a favorite? Okay, I think we got too many smart people here because I think you got that I was tricking you. We don't have any public spaces with the web. In reality, we have a public directory so we can know where to get to, and we have a spec that is open, and thus the spec is kind of public in that way for how we can ask a server for something and how that server will respond so that we're all on the same network. But everything on the web, once we navigate that directory and we get to a piece of the web, it's private because it's running on someone's server somewhere, and that's the only way you can get to something on the web, which means as an actual result, there is no public space for the web. And if we didn't have a public space in reality, we'd be missing a lot of things. Our kind of right to free speech is really based on the fact that we all live in a public space with each other and we have a voice that can reach one another. But if I enter a private space, they have certain rights over what I can say. And what we're trying to do is we're trying to say, if we apply this same concept to the internet, we're gonna be able to solve a whole lot of problems. So, how did we go about doing that? First, we recognize that a blockchain is a public database of signed and timestamped statements. With Bitcoin, these statements are about transactions. They're movement of money. They're very similar to like a check, right? I just need to write a check, I need to know who I'm sending it to, put a number in it, and sign it. And then once the bank validates it, make sure that I had that amount of money, the other person has that money now. It's very similar to Bitcoin. Each Bitcoin transaction is just another one of those statements, right? And the result of it being public is that it's a triple accounting ledger. It's totally transparent, and everyone knows the person that sent the money, the person that received the money, and everyone else can validate it. Now, we have another blockchain that was started 4 years after Bitcoin. It's called Flow, and it's very similar to Bitcoin. It's a proof of work blockchain. The biggest difference is just that it explicitly allows you to put any data that you want into a transaction. You can put up to 1 kilobyte of data, and you pay for that with the size of your transaction fee, right? So because this is a permissionless blockchain, the same way Bitcoin, means we can't stop anyone from using it. Anyone can use it. And if this blockchain can store arbitrary data, then it means anybody can put up arbitrary data, basically making it a public space, essentially. And what we then did is we added Open Index Protocol. And Open Index Protocol is an indexing specification on top of that. And the result is that you have an indexed public space. What Google is kind of the closest thing to this in that it's most effective at delivering search results because they have the largest index of the web. The web itself doesn't have an index, so all the indexes we have are proprietary. They're built by the application layers that we actually use, right? And because they have such a large one, they've been able to leverage that to give us a lot of services. And it kind of feels like a protocol in that sense. We get a little bit of Google Docs over here and Google Maps over here, and they all integrate together because of how this is all set up. But it's not a protocol because they're proprietary, and they're using it to sell our private data, right? So if we can shift that from proprietary and controlled by one of the biggest tech companies in the world to public and controlled just by the individuals who put stuff into it, it'll make a big, big difference. So the characteristics that we needed as we were building this, first it needed to be absolutely decentralized. If this is going to be the public space, then no one should have the ability to manipulate it, leverage it, remove things from it, etc. Which is why, in our opinion, a proof of work blockchain was really a perfect solution for this. It needs to have an immutable history so that if something is put up, you know that it'll always stay there and it's not going to turn into something else. It needs to have file persistence. So when I put up a file itself, I'll know that it'll always be there. Running into 404s is not a really good thing. You know, we want to make sure that as we put things into the internet, they stay there. It needs to be defensible against even state-level actors. If someone else wants to change this information, we need to make sure that the protocol itself is able to stay robust enough that it can protect the information for the people that are putting it up for them. It needs to stay permissionless so that no one has to get anyone else's okay before they can start participating in this system, either by putting content up or selling content for other people. It creates a level playing field. One of the biggest problems that we have with iTunes and Spotify is they don't have a level playing field. They're actually trying to compete based on what's in their index, not how good their application is. And because they can compete based on what's in their index, they don't care to compete based on how good their application is. If they were competing based on how good their user interface was, or their suggestions, or their discovery and filtering was, we would enjoy the experience quite a bit more, I can guarantee you. It needs to be salutary. I'm not going to explain what that means too much yet, but it just means that it's sustainable for the participants that are using it. And it needs to be anti-fragile. I know that's kind of a buzzword, but essentially what it means is rather than when you throw, I don't want to use the word chaos because I have a scientist next to me that will correct me on it. When I throw randomness or just random stuff, disorder, yeah. When I throw disorder at a system, normal systems will break down as a result. Resilient systems will just stay strong. Anti-fragile systems will get stronger as a result of throwing more chaos, more random Sorry. So our approach, as simply as possible, is to take all the file that's being put up, turn it into an IPFS object or a BitTorrent object, and get back from that the locator hash. The locator hash. If you know that locator hash and you're on this network, you can find it. It doesn't matter if any changes that are made or anything like this, you can always find that file. That's a big deal. Then we take that information, we add it to a description about it, metadata that describes what it is, the title of it, the person that made it, background about it, tags, etc., as well as commercial prices. Say it's a song and I want to distribute it for 1 cent to listen to and $1 to buy, right? And last, I put it all together, I sign it with my cryptographic signatures, with my private keys, and then I put it into the blockchain using a transaction that has a little publish fee. So let's just actually kind of look at what that looks like. In most cases, what it'll actually mean is that someone's interacting with a normal server on the web. It's just that instead of that server on the web being the only recipient of what's getting put into it, it's getting pushed out to this protocol. And the way that'll work is that Alice comes along and she has a file that she uploads to a web server. That web server adds the file to the IPFS network, and it gets back that hash. Once she's got that hash, she puts it into the Florin Coin blockchain. She's not doing this manually. The web server is doing this all for her. She then signs it, and it starts getting distributed into the network. So now it's in the open index, and it's floating around, right? And another platform discovers it, this one over here that Bob is using. So Bob first reads the index. He sees this new thing that has been added to the index. He says, oh, this looks interesting to me. And he checks it out, and he starts retrieving the file over IPFS, right? And then he's like, oh, this is fantastic. I love this. So I'm going to go ahead and send her a tip. And because she included her Bitcoin address in what's called an artifact, the thing that she published, he's able to send her a tip back on Bitcoin. Now, here's the thing to note. The way we built it is that all the transport protocols are interoperable. So file transport is interoperable. Right now, we're supporting IPFS. We started with BitTorrent. We can add more file transport protocols. And value transport protocols are interoperable. So Bitcoin, most people use Bitcoin, but Bitcoin Cash is another approach to how we're going to scale, and Bitcoin Lightning Network is another approach for how we're going to scale. We can also support Ethereum and every single crypto that there is so that you can increase the chances of the person that needs to get paid and the person who has the money to pay are going to have the same coin, and they can quickly interact with each other. Now, that's the kind of basics. Bob sends it. It gets back to Alice. But in many cases, there actually is a middleman involved, right? We like to talk in this decentralized world where it's just Alice and Bob and they're the only two parties involved and that's all that really matters. In reality, often there's a middleman. There is a Charlie who actually helps out. And in this case, Charlie is an influencer. So very similar to Amazon affiliates, this is just someone that goes around and just shares links on the web to things that they think people are going to like. And if they do like it and they buy it, that influencer is going to get a cut because they helped, right? And in many, many cases, there's going to be even a fourth party. There's going to be Dave, our platform server. They're doing a job too, because they're not just hosting the files, they're also doing things like suggestion algorithms and filtering algorithms and make sure that any of the stuff that their audience isn't going to like aren't in there, and they're just getting pushed the stuff that they're very likely to like. So if they help in that sale, they're also going to get a cut. So what it actually looks like is this simple. It's just JSON put in a blockchain. This is one of the very first artifacts that we put up. Of course, it's a cat video. We had to do it that way. And as you can see, this is actually before IPFS existed. We were using BitTorrent magnet links for it. And so this actually is a fully transparent or a fully decentralized system in that you get the file without needing any central points of failure here, and you can find the file through the index, which is on a blockchain that no one can censor, no one can shut down. But it's come a long way since there. That was about 3 years ago. Where we're at now, this is our artifact inspector, so you can actually see it. So the spec has expanded quite a bit. And you can see that we've started adding a lot of extra metadata to describe each piece of information that we're putting in here. Some of this stuff looks a little weird, but it's very similar to the way it used to be. We can show what network it's on. Here's all the individual files in this particular artifact. And it's signed. In this case, there's no payment. It's signed. It's very similar to the first one. It's just we're expanding it, right? So, but to talk more about, oh, I'm sorry, I don't want to get off that. So in this case, it's using what's called multi-parts. This particular piece of information took more than one transaction put up there. So it split the information into 2 transactions, and it reassembled them back together so that it can then put that into a database on a web server and make it really easy to access.